Hello, Matric's getting there. Right, we're going to look at confidence intervals for population proportions. It's very similar to, it's almost exactly the same as confidence intervals for the mean. So previously we wanted to find a parameter where we could say with a certain degree of confidence that the population mean will lie within a certain region based on the sample mean, standard deviation, and the size of the sample. We're going to do the same thing with population proportion now, instead of with mean. We want to be confident that the actual proportion of something happening lies within a certain region, based on a sample. So that's what we're going to be doing today. You're going to need the notes I sent you, the affiliate notes for population proportion. So you will be working with these notes over here. Confidence intervals for population proportions. So a proportion is, as we said over here, proportion is a percentage of the total population that is something or other. By property they mean characteristic. That is some characteristic. So that's a proportion. So they look at the example of cars. If you had to take everyone in the car, 18 million out of 30 million have a car. Nowadays it's that high. Which is 60% of people have a car. I would say probably more like 15% in this country. Okay, so the notation we're going to use, is from the sample, just like x bar. Okay, we had x bar was the sample mean. Okay, and from that we estimated the parameters for a confidence interval for the population mean. Okay. What we're going to do now is we're going to say the equivalent of the population mean. We're going to talk about a population proportion, so the proportion of people that have a certain characteristic, and we're going to just call that P. The P is going to be equal to the population proportion, and the sample proportion we're going to call P hat is equal to the sample proportion. So from the sample, okay, so those are equivalent. X bar is the sample mean, P hat is the sample proportion, mu is the population mean of the whole population as opposed to sample, P is the population proportion. So in this case over here, P was your population proportion because we looked at the whole population, which is 60%. Okay, but again, realistically, it's impossible to survey the whole population, so we're going to take educated guesses by taking samples. Okay, and the sample space, as we said, is going to be called P hat. Okay, and to find a proportion, it's very easy. If you had 500 people, 320 of them have a car, the population proportion, is going to be 320 over 500, which is 64%. So P hat is 0.64. So P hat is equal to this. X is the number of successes, like 320. What we wanted, n is the size of the sample. Okay, and we're going to find confidence intervals for population proportion. So the formula says this: the parameters for your confidence interval, P. Okay, so remember what we're going to do now is we're going to have a situation like this. Previously, we looked at sample means. We looked at means of samples. Here was your actual mean of your particular sample. Based on that mean, we found parameters, a lower boundary and an upper boundary based on the z-score and n and standard deviation, where we expected to find mu. Okay, so mu was based on the sample mean. Now what we're going to do is we're going to have P hat, so P based on sample, there's going to be P hat, okay, your sample mean, and we're going to get a confidence interval, the lower boundary and an upper boundary, where we can have a certain degree of confidence that the actual population proportion lies within that region. So we're finding the boundaries for P, the confidence interval for P. And the formula is over here. P is equal to P hat plus Z. Well, Z is based on your the confidence interval, the Z score for your confidence interval. P hat 1 minus P hat over N. Okay, and so in this formula, okay, the population proportion is P. Those are the boundaries for the population proportion. The sample proportion is p hat, okay? The sample size is n, okay? And z is the z scores for the confidence interval. Now, if you go to your information sheet, it looks slightly different. Okay, so it says over here, it's not on your information sheet, but it kind of is, but it's just written in a different form. So you should really add this into your, whenever you get a formula sheet. Formula sheet. Okay, so you're going to have P is equal to P hat. So I want you to fill in the hat. They haven't written the P here, but that should be a P is equal to P hat. Okay, fill in the hat. All of these things should have a hat on the formula. P hat, 1 minus P hat over N. And that's just your population proportion. So you get P is equal to P hat. Just like over here, they didn't fill in mu. Okay, mu is equal to X bar. Here you should fill in P is equal to P hat, okay, etc. Right. So it's kind of on the formula sheet. Just remember that the P's written down there are what we refer to as P hat. In other words, your sample proportion. Right. Get straight into it. Okay, so your first example says, a food company, wants to estimate the proportion of the South African population that are vegetarians. The company collects a random sample of 1,000 citizens and finds that 200 of them are vegetarian. Find a 95% confidence interval for the true population proportion of South African vegetarians. Okay, great. So you're going to say, all right, first of all, what's our sample mean? P hat. Well, to find P hat, what happened? You had 200 people were vegetarians out of a sample of 1,000, right? Okay, and 200 over 1,000 should be equal to 0.2. So in other words, 20%, according to this survey, of South Africans are vegetarians. Okay, right. So straight away, I'd say you've got a very biased sample space for South Africa here. Somebody went to the northern suburbs, okay, and had a look at this. Yeah, there's no way that's accurate. Sorry, vegetarians, you're a minority. Okay. So then it says, we want a 95% confidence interval for the true population proportion of South African vegetarians. Well, first of all, we've got n is equal to 1,000, and we've got a confidence interval we're looking for of 95%. So what we've got is we've got P hat, our sample proportion, okay, is sitting at 0.2. Okay, and we want to find the upper boundary and the lower boundary where we are 95% confident. So this whole area here is 0.95. 95% confidence, okay, that the actual proportion of vegetarians lies within that region. Okay. So first thing we have to find is our Z scores for 95% confidence interval. So remember, this is 0.95. If I go 0.95 divided by 2, 0.95 divided by 2 is equal to 0.475. So we're going to use the H of Z score, which is equal to 0.475. Okay. So now we need to find the Z score that goes with that. So we go to our table. We've got the H of Z, we've got the area, which is 0.475. That's it over there. So we're going to use 1.96. Okay, 1.96 is going to be what we're going to use. Right. So we've got a Z score of plus minus 1.96. So your Z boundaries are 1.96 minus 1.96. Okay. And now you got your formula sheet. Okay. There's your formula over there. Okay. So you're going to have P is equal to P hat plus minus the Z score square root. It's all under a square root. Okay. All under the square root of P hat 1 minus P hat, okay, over N. Right. So I'm going to have your parameter boundaries are going to be P is equal to P hat. P hat was 0.2 plus minus your Z scores are 1.96. The square root of P hat is 0.2. So 1 minus P hat will be 0.8 over N, and N is equal to, N was equal to, you had a sample of, sorry, N was equal to 1,000 citizens. Okay. So over 1,000. Right, let's chuck that into our calculators. So you're going to get 0.2 plus 1.96 times by the square root of 0.2 times 0.8 over 1,000. And I get 0.22, so that's going to be your upper boundary. Let's do it to 4 decimal places. 0.2248. Your lower boundary, well, let's just go back and change the plus into a minus. Okay. And you get 0.1752. 0.1752. Right, so what does that mean? Okay, that we can be 95% confident that the proportion, so we're looking at proportions now, not means, of vegetarians is between 17.52% and 22.48%. Yeah, as I say, if only. Yeah, right. So that is that. Okay, so it's not too bad, kind of similar. Okay, just remember to alter your formula on your formula sheet. Okay, alrighty. Okay, example 7. Okay, just check if you've got that all down. Press pause if you haven't. Right, example 7 says, a social media group wants to estimate the proportion of teenagers that use Instagram. Out of 500 teenagers interviewed, 370 of them use Instagram. Find a 99% confidence interval for the true proportion of teenage Instagrams. Well, first of all, let's get the sample proportion, P hat. P hat's going to be 370 out of 500. And 370 divided by 500 gives us an answer of 0.74. So according to this sample, 74% use Instagram. Okay. Right, we want to find a 99% confidence interval. So for 99% confidence interval, so what have we got? That whole region must be 99%, which is 0.99. Our p hat value, which is in the middle of this thing, is 0.74. Based on that, we want to find a lower boundary and an upper boundary. And within that, we can expect 99% confident we can find the actual proportion of teenagers who use Instagram. Right. So the first thing we have to find is for a 99% confidence interval, what the Z score is going to be. So if that's 0.99, then this is 0.495 if I'm correct. 0.99 divided by 2, 0.495. So we're going to use the H of Z score is 0.495. The H of Z, so you probably can't see that, is 0.495. So I go to my table. I look for 0.495, which is that weird one in between here. And this is going to be 2.576. It's between 2, or you could use 2.575. So you're going to use a Z score of 2.576. So Z is equal to plus minus 2.576. Okay. Right, so now I think I've got all the parameters we need. What was N? N was equal to 500. Okay, so we're going to use our formula. P is equal to P hat plus minus Z. P hat 1 minus P hat over N. Okay. Right, so in this case, I'm going to have P is equal to P hat, which is 0.74. Plus minus my Z score is 2.576. Okay. Square root of P, which is 0.74. 1 minus 0.74, 1 minus 0.74, I should do that in my head, is 0.26 over N, which is 500. And we end up with P is equal to. Okay. So you're going to get 0.74 plus 2.576 2.576 times the square root of 0.74 times 0.26 all over sample space of 500. And let's have made a careless mistake. So our upper boundary should be 0.7953. 0.7905, sorry, 0.7905. Okay, and the lower boundary, if I go back and I change the plus to a negative, okay, I end up with 0.6894. 0.6894, what does it mean? Okay, if we round it up, round it off, as a percentage, it means between 69% and 79%. Okay, we can be confident, we can be 99% confident that between 69% and 79% of teenagers use Instagram. Probably more like between 89 and 99%, except for those parents who are decent and kick your butts. Right. Amber is not on Instagram. Actually, no, she's not. Right, she's on Snapchat. Okay. So guys, if you remember, in the survey, in this formula, you've got P minus P hat, okay, is equal to, and I say, give it in the format they give us. P is equal to P hat, okay, P is equal to P hat plus minus Z P hat 1 minus P hat over N. So just like we had the standard error from the mean, okay, was the absolute value of mu minus the sample mean. I could look at it like that. It's equal to absolute value of Z. I'm just getting rid of the negative values. And so basically, you're just looking at the upper boundary if you want to think of it like that. Okay, this was your error between your population mean and your sample mean. Okay, and the bigger the Z score, the bigger the error. Okay, in other words, the sigma is the standard deviation. That was the sample size. So that was your error. That's just idea for it. They say it has to be within this. Within that, go find sigma root n or z, something like that. Here, with population proportion, your error is going to be, I want to get rid of the whole thing of the negative z, p minus p hat. That's going to be your error between your population proportion and your sample proportion. So that's going to be your error, your differences, whatever. And you can think of it as being the absolute value of z, p hat, 1 minus p hat over n. Okay, so that is going to be what gives us our error, okay, which is what we're going to be looking at in this question. Okay, so it says a recent study estimated that only 4% of the world's population have green eyes. So what is that thing over here? Okay, 4%, oh, green for green eyes, okay, have green eyes. So that's a study. So that's our sample. So p hat is equal to 4%, which is 0.04. How large a sample they're looking for? So they're looking for n. Needs to be drawn to be 98% confident. So we're looking at a 98% confidence interval. Okay. That the estimated portion of green-eyed people does not differ from the true. So they want to know the error. They want the error, okay, to not be more than 1%. So the error must be less than or equal to 1%. Okay, so that's what we're working on. So what is your error? Your error is p minus p hat. So if we look at your error being 1%, p minus p hat is equal to 0.01. That's going to be our starting point. Okay, so in other words, but what is our error? P minus p hat. Okay, well, p minus p hat is equal to z is equal to z p hat 1 minus p hat over n. So it's going to be what we're going to be using. Okay. 0.01 is equal to z. Okay, so that is your error. Okay, how much is the difference between the sample proportion okay, and the actual population proportion. That's your error, P minus P hat. So now I've got to figure out, first of all, to do this, I've got P hat. Okay, P hat we've worked out over here. P hat is equal to 0.04. Okay, I'm looking for N. Okay, the only thing I've got to go find is a Z score that goes with a 98% confidence interval. So if you've got a 98% confidence interval, okay, so here's P hat. If that's 0.98, then your H of Z score is 0.98 divided by 2, which is 0.49. Sorry, I'm very tired. I'm not doing much mental math. So I've got to go to my formula sheet and look up 0.49 in order to get my Z score. So that's my area. So my area is 0.49, and 0.49 okay, was over here. That's the one that's pretty close to that. So we're going to use 2.33. Okay. So we're going to use a Z score of plus minus 2.33. Okay. So here, so now I can go in there. So I'm just going to use a positive. So I'm going to have 0.01 is equal to 2.33. P hat is 0.04. So 1 minus P hat is 0.96. Okay, over N. Right? Okay. So we can go divide, square, flip, invert, do all of that kind of thing. But just for fun, let's remind ourselves of how we use the solve mode. Remember, solve can only give us one solution, but there's only going to be one solution here. So let's try it. So we're going to go, I'm trying to remember how this works. Point, okay, let me see the calculator. 0.01. Okay. Then we're going to go, don't use your normal equal, remember, go alpha equals 2.33 square root of fraction 0.04 times 0.96 over our variable, which is alpha x. Remember, now don't press equal, press shift and solve. Solve for x, and we're at. We have a cup of tea. Oh, it hasn't taken too long this time. And we get an answer of, press equals again, 2084.69. Okay, so in other words, to have an error of 1% or less, you must have at least 2,085 people must have their eyes tested. Okay, must be surveyed. So that's what N must be. Okay, so remember your error, just like another one, okay, is that whole scenario over there. Right, last one. It says, a recent poll conducted on the proportion of Americans who are in favor of Donald Trump building a wall on the Mexican border revealed the confidence interval of, so this is a proportion of people who want a war, okay, is stacked between a war, which will of course never happen, never was going to happen, okay, was, okay, your lower boundary and your upper boundary. So here, remember, P hat's in the middle of those. Okay, just like, remember if we had the upper boundary and the lower boundary of a confidence interval for population mean, the sample mean was right in the middle of that always. Same thing with population proportion. So your sample proportion is going to be in the middle of your upper boundary and your lower boundary. So your lower boundary is 0.15, your upper boundary is 0.35. Okay, so P hat will be in the middle of those. So P hat will be 0.15 plus 0.35 divided by 2, which will be 0.2, 0.5 divided by 2, which is 0.25. So there is P hat. Okay, so now we've got P hat. Okay, this is the estimated proportion of Americans who are in favor of the war. Okay. I would have said, what's the sample proportion instead of the estimate proportion? Okay. I would have made that question. What is the sample proportion of Americans who are in favor of the war? Okay, and that's sitting at 0.25. Right. Next question says, if 52 people were interviewed in the poll, so now we know P hat is 0.25, That's what the sample mean was. N is equal to 52 people were interviewed. Find the confidence interval. So we're looking for the confidence interval, right? Okay, used for the poll to the nearest percent. So if we just get confused, go to your formula and say, okay, help focus your mind. P is equal to P hat plus minus Z, okay, P hat 1 minus P hat, okay, over N. Okay, so if I go use that, okay, what are we looking for? Well, there's no confidence interval there, but what's related to the confidence interval? What's related to the confidence interval is Z. So if we can find Z, we can find H of Z, which means we can find the confidence interval. So our plan is to go find Z. Once we find Z, go find H of Z, then use your info sheet, your data table. Okay, well, I do that. Okay, I find Z. From Z, I use my table, and I find H of Z. I times H of Z by 2, and that'll give me my confidence interval. So that's my plan. So first of all, I've got to find Z. So, and we've got to just use one boundary. So let's look at the upper boundary. So if I look at the upper boundary, okay, you're going to say 0.35. You could use the lower boundary as well. So I'm going to use the positive Z score. Okay, 0.35 is equal to 0.25, or you could just look at P minus P hat, which is the difference, which is 0.1. Okay, plus minus Z. Okay, here you're going to have the square root of P hat is 0.25. So 1 minus P hat is 0.75. Okay, and the sample size N was 52. So now you've got to solve for Z. Okay, so if we do this on my calculator, let's try doing one step. You're going to go 0.35 minus 0.25, which is 0.35.1, but just to show you. Okay, so now I'm on 0.1. Okay, then, so I'm going to have 0.1 is equal to Z times this whole mess. Okay, so you've got to get rid of that whole mess. Okay, so you're going to go 0.1 divided by this bit over here. You could go use your solve button, but you're going to, sorry, there shouldn't be a plus minus, it'll just be plus Z. Okay, so you're going to go 0.1 divided by the square root of 0.25 times 0.75 all over a sample size of 52. Okay, and we get a Z score of 1.6. Remember, Z scores are only given to 2 decimal places on the table. So you get Z is equal to 1.67. That is not your area, that's your Z score. Okay, so we've got a Z score now. Okay, so that's a Z score of 1.67 up there. That's a Z score of minus 1.67 over there. What are we looking for? Okay, we're looking for this area over here. So we're going to use the 1.67 to get H of Z, which is going to be that area there. Okay, so we got our table. We go find H of Z. Okay, and H of Z 1.67. 1.67, a Z score of 1.67. 1.67 is over there. Here's 1.67, okay, which is 0.4525. 0.4525. So this area here is 0.4525. Okay, so H of Z is 0.4525, which implies that your confidence interval is going to be that times by 2 to get the whole confidence interval. Okay, so 0.4525 times 2. Okay, 0.4525 times 2 equals, so it's a 90.5% confidence interval. Okay, 0.905, which is approximately a 90% or not confidence interval, or 91% confidence interval, doesn't matter which one you put. So 90.5% confidence interval, okay, was used for this survey. All right, guys. It's kind of similar to what you've done. So I want you to do exercise 2, just a basic one like number 1. Those are all pretty basic. You're welcome to do number 3 as well. Okay, but then I'd really like you to try these ones with N. So 6 and 7. Okay, so 1, 3, 6, and 7, please, from your exercise. Remember, it's on team. Okay, and that's it for now. Okay, good.